Hello, everyone. Good morning, dear authors and invited guests. Welcome to the technical session 5F. My name is Siddhi Auti, and I'll be your session moderator for today's session on the behalf of Global Knowledge Research Foundation. It is my great pleasure to welcome you all to the ninth International Congress on Information and Communication. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London on 90th and 20th Feb, and the virtual event is being held yesterday and today, 21st and 22nd Feb. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, there will be 6 presentations, and each presenter will be given 12 minutes of time to present their presentation, and 3 minutes will be given for the Q&A session. I request all the participants to please consider the time constraint. I'll be raising a reminder in 10 minutes, and after that, you will have to conclude your presentations. Thank you. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or technical issue or anything, you can contact me in the text chat box. You can text me. Now, just before we get started, I would want to introduce the session chairs for today's session. Uh, Ma'am, thank you so much. Hmm. So our first guest is Millie Kitsing, ma'am. They are the author of the Political Economy of Digital Ecosystems. They are the rector and professor of political economy at the Estonian Business School. Previously, Kitsing worked as head of research at Foresight Center, a think tank at the Estonian Parliament, and advisor at the Strategy Union of Estonian Government Office, and head of economic analysis at the end of the Estonian Ministry of Economic Affairs and Communication. And our next guest for today, uh, so our next guest, are Dr. Nimisha Patel. So she has 19 years of teaching experience in the field of computer science and engineering. She is currently working as a professor and HOD in CIT Gandhinagar Institute of Technology, Gandhinagar University. She has worked as a dean, faculty of computer science, Sakalchand Patel University, Visnagar. Her area of domain is cloud computing, networking, information security, and parallel programming. Now we will be starting with the papers. So I introduce the first presenter for today's session. Ma'am, can you please change the slide? So the first presenter of today's session are Alexandra ma'am. Ma'am, you were there for the last session as well. Hello. I request you to please start your presentation.
Thank you. Good morning, everyone. I'm Alessandra Michalizzi. I'm Associate Professor at Pegaso University, and today I would like to share you the first results of our research. I'm responsible for Digital Humanities Center, and we are working on prejudice and perceptions about artificial creativity. The focus of our research is music production specifically. I try to describe the roadmap of my presentation. So we have first a focus on the concept of creativity and art, some perspective over the application of artificial intelligence to creativity, the artificial intelligence productions with a very quick state of the art, and then the presentation of our research and the main results. When we try to define creativity, we had to make a choice, and we are close to the definition proposed by Bowden that describe creativity as novelty, surprise, and being valuable. She distinguished 2 types of novelty, one representing something new for the creator, termed psychological creativity, and the other pertained to being new to society, known as historical creativity. According to Merriam-Webster, art is a conscious use of skill and creative imagination. So as you can see, we can associate creativity as a practice extremely as a skill or a practice strictly linked to the concept of art. Duchamp introduced another nuance of the concept of art, of the art world, that in his perspective is relied on the determination of artists' intention, institutional display, and audience acceptance as critical defining steps to discern what is art. So in some ways, we need to be accepted by the audience to consider an artwork as something that is part of the art world. Moreover, Ertzmann argues that art is essentially a social behavior, and this is an interesting aspect because I'm a sociologist and psychologist. So my focus is on the perception of the audience and the shared recognition as an art production. In this perspective, art is an interaction between social agents, the audience and the creator. Here there is one of the process followed by artificial intelligence to create something new. So is exactly what we described before, is a collection of something that is already present, that already exists in our storage of creative content. And with this specific model is introduced something new to have a final production that involved, in any case, the artist in all of the steps. More than one point of view we have more than one point of view in the application of artificial intelligence in artistic production. For example, Ertzmann argues that there is a bias at the basic of this reflection of this discussion, because he considered the use of intelligence not appropriated in the case of artificial intelligence applied to art production, because these create an anthropomorphization of the technology that contributes to assign them a level of human understanding that is not with their capabilities, their skills. So it is true that the artificial intelligence produces something new, but is not aware of what it is going to do. The premises of our research are the following ones. Creativity is something that belongs to humans and intercepts the concept of novelty. New versions of machine learning algorithms can produce something new. Art is a form of expression of the human creativity and requires not only skills but also novelty, even if generated by references coming from the past. So we designed a research that recalled the imitation game of Turing. So we use a 3 groups experiment in which we try to test the affection, the influence of the authoriality of the authorship of the music production in the perception of the public. So we have the first group that is not informed about the authorship of the 2 music tracks that they were going to listen to later, and 2 groups in which we inverted the information. So the second group was defined as well informed because they know which one of the 2 tracks coming from artificial intelligence. The third group is defined misinformed because they have the information inverted. They have a first profile questionnaire, then an interview, the listening, and then a second part of interview. The not informed group has only the profiling questionnaire and not a first interview before listening, because the interview has as an object the topic of the artificial creativity or computational creativity as is defined. So we don't want that, we don't want to create a framing effect in their perception and listening. Sorry. What we These are just the first results based on 3 groups of 10 people. So we have a sample of 30 people, but we are going. It's a work in progress because we extended our sample to reach 100 people, and we divided the groups with a subsample of experts in music or in creative production and not expert people, so everyday listeners of music. These are some the first considerations about the relation between creativity and artificial intelligence proposed by the well-informed and misinformed groups. Art or music produced by a computer is less worthy of attention. The technical aspects prevails over the art. Computational creativity reduces the role of the artistic and human creativity. So as you can see, we have the first construction of the prejudice about the relation between artificial intelligence and creativity, and several worries about human roles in the process of productions, even if it's considered as an opportunity that, if used consciously, could have a good impact in the music industries and in the construction in the construction of our cultural artifacts. Here we have the responses about the well-informed group. As you can see, the first track is the one produced by human. The second track is the one produced by artificial intelligence. They have the correct information and they preferred the first one. Especially in the general appreciation, and as we can see, the balance and also the emotional impact. When we look at the misinformed, we have speculative results. So they prefer the second track on the first one, so the one that is produced by artificial intelligence, but they knew that is the one produced by human, especially for the emotional impact. If we look at the results of the not informed group, we have a more balanced results. And what is, I think it's noticeable, is the fact that the emotional impact is higher for the track that is the one produced by an artificial intelligence, even if this group hadn't any kind of information about the authorship of the music tracks. When we asked them if they, for example, buy the music, the track, or introduce the track in their playlist, as you can see, not informed are extremely balanced. Well-informed prefer the first one, so the track produced by human that they know is produced by human. The misinformed as a specular result, so they prefer the second track that is the one produced by the artificial intelligence indeed, but they believed is the one produced by human. So what we can say is that there is a general prejudice that is that has an extreme impact in the evaluation of the tracks. And even if I haven't an histogram to present the difference between the group of experts and the group of everyday listener, we can have also in this case an interesting difference in the sense that the most worried are the experts one, because they believe that the most worried and the most critical about the final production, and in any case they are not able to specify which one, to recognize the track produced by the artificial intelligence, even if when they have the misinformation or not information. And I think is interesting because sometimes they express judge linked to the quality of the track, because the one produced by human is written and executed by by a pianist, a young pianist that is at the beginning of his career. So probably there is an ingenuity in his production. However, there wasn't no one that say, okay, there is a mistake. This is the one produced by human and not on the contrary. And I think it's just an interesting result. As we can see, there is a prejudice, but with the final collection of their positions, we also highlight an awareness of this prejudice. So it is more challenging. For example, these are some quotations of the interview. It is more challenging to establish a connection between myself and the composer if the latter is a machine. I'm acutely aware that my evaluation of an artwork is influenced by the identity of its creator. I believe this is a natural inclination. It is not solely the result that holds a significance, but also the identity of the creator. Does it not? If not, what then is the significance of the creator in the process? They can make all the difference. The computer is a medium, much like a paintbrush, a color palette, or a musical instrument. If the foundation of a work lacks research, study, culture, and substance, whether produced by the human hand in the traditional manner or by artificial intelligence, its artistic significance diminishes. So, in this quote, we can see how there is an attempt to appropriate, to integrate artificial intelligence as a tool and not as a competitor of human production, but something that could be useful, could be used to produce music if it remains the idea that art coincide is overlapped with originality, is something that is not listened before, even if produced by a search work, a study, a cultural reference to the tradition and the roots of the culture. Thank you for the attention. If you have any question, you can ask me or you can write it later to my personal email. Thank you.
I think, thank you so much. I mean, I think we actually don't really have time for questions. I can give some comments in the end, very quick ones, because we only have 12 minutes per participant. And I'm sorry, like it's really tight schedule here, and we have already like used more than meant for one participant. So I can give like in the end, hopefully some quick comments or just write them in the chat. But I think it would make sense actually to move on to the next presentation, because otherwise we're running out of time, and I have another appointment right after this session. So can we go to the next speaker?
Yes, sir. We'll proceed to the next speaker.
Libero Nigro, right?
Yes.
Yes, I am. I try to share my video.
So the next presenter for today's session is Libero Nigro, sir. Sir, are you present in the meeting? I request you to please start your presentation.
Okay, if you allow me to share my video.
Yes, I'll stop sharing my screen, then you may share.
Is my video visible?
Sir, I can't hear you properly. Can you repeat?
I try repeating now. Okay, it's okay?
Yes, we can see your screen, sir.
Okay, thank you. My name is Libero Nigro from University of Calabria. And I will talk about our current research project, which is aimed at trying to improve the performance of K-means algorithm. It is well known that K-means is very often used as an unsupervised clustering method because of its simplicity and also efficiency. But K-means has also some limitations, some problems. And so we try to propose a variation of the k-means clustering, trying I repeat, trying to go better, to achieve a better, accurate solution. Now, I would just give you a few words about the background. We are interested to the unsupervised clustering, in which we try to split the data point in a given data set in groups, say the clusters, according to a similarity metric. Normally, if we have a data point, we use the Euclidean distance. Now, each cluster is represented by its centroid, which normally is the mean point of the belonging point to the same cluster. Now, when we apply a clustering algorithm, a clustering method, we have some function cost which try to optimize, minimize. For example, typically, usually, is the sum of squared error metric function cost, which we try to minimize in the sense that sum of squared error are the sum of the distances between each point and its nearest centroid. In a similar way, we can use the distortion, which is just a mean of the SSL. Now, k-means basically repeats this point, these steps. First, centroids are initialized according to some seeding method. For example, also random, in the sense that we initially choose randomly k points from the dataset, assume them as a starting point. But the basic steps are 2 and 3. In the step 2, we partition a point according to the nearest centroid, in the sense that we assign a point to a cluster according to the minimal distance to centroid. After the assignment, which is a partitioning, we update the centroid by calculating the mean point of each resulting cluster. Then we check termination when we can say if we can see if centroids are stabilized or not. If not, we repeat from step 2 and then 3. Now, k-means strongly depends on its initialization of centroid, the seeding method adopted. And what all of us know about k-means is that it tends naturally to be stuck in a suboptimal local solution, in a sense that k-means is unable to try to globally search for the optimal solution. Common remedy, we repeat many times k-means, repeated k-means, by executing error-independent execution of k-means, obviously each time with a new seeding, a new initialization, and then we choose the best emerging solution. Now, I have no time to go in depth about some methods, and I would only point out the problem which we have with the k-means, the basic problem, limitation. If the seeding method wrongly associates, for example, multiple centroids to a given real cluster, like this, we have multiple centroids, the two green, for example, here, and there are also some real clusters which have less centroid. But if the former area are well separated from the areas where we lose centroid, we cannot move centroid from a real cluster to another. So this is basically the difficulty of k-means in its standard usual definition of Lloyd's k-means. Now, what we have done, what we are continually done in this moment, we have defined a variation of k-means which is basically around this concept. We use a formulation which is evolutionary way based, and we build, in the first case, we build a population in which we accumulate some exemplar centroids. Then, after population setup, we recombine the solution in the population through careful seeding and experimentally confirmed. Such a recombination allow us to move toward an accurate solution. Our variation, K-means inside PB, K-means population-based K-means. But what we described, which is new in this paper, is the way in which we build the population, which is based on a refined method, which we have achieved from a known initialization method in the literature, which is the Bradley-Fayard refined method, but we have modified this method. What we do in brief is the following. First, we take the data set and split it into a number of disjoint segments. Each separate segment is then clustered independently using kappa means and also some seeder, already known seeder, also uniform random, for example. In this way, we achieve a safe solution where each solution is characterized by K-centroid, K-cluster. And what is very important is that these partitions are necessarily disjoint one to another. Then what we do is to use a deterministic method to merge the SF per K centroid until we achieve exactly K centroid. And what is very interesting is that we use the pairwise nearest neighbor in the sense that from time to time, we select the pair of clusters whose merging would increase the distortion list minimally, okay? And being the cluster disjoint, we can anticipate what will be the increase in the distortion, in the cost, and also we can anticipate the new centroid of emergent cluster, okay? Now, here we repeat the formulation, abstract formulation, which we build the population, and during the population, we anticipate two parameters, the number of split factor, the number of segments in which we must split the data set, and also how many solutions we want. And the first step generated the population with the J per K centroid. Now, the essential point is that centroid in the population are very, very interesting because among the centroid we can choose exemplar, what we have called the exemplar. Exemplar are centroids which are close to the ideal ground truth centroid. In this way, in the second step, we have a high probability, and this is experimentally confirmed, that by recombining by using repeated kappa means with the R repetition, we can recombine the exemplar toward an accurate clustering solution. And so during the second step, we do the recombination, and we use also some greedy K-means plus seeder method, which allow us to easily select the exemplar. Now, we have implemented such variation of K-means in Java. This is just the pseudocode. And we use parallel Java in the sense that we use a parallel stream and lambda expression. I have no time to give you technicality aspects. But what I would stress is that Our implementation is capable of exploiting the computing potential of modern multi-many core machine, okay? So we use parallelism, for example, for accelerating the key means operation, for calculating the function cost, to improve, to implement the PNN realization and so forth. Now, I try to give you briefly some results. We have chosen both synthetic benchmark dataset and also real-world dataset. And these are some datasets which typically in the literature are chosen to test some new version of a clustering algorithm. And what it is important to stress, all these datasets which are publicly available from the Professor Pasifranti in the Finland. And what is interesting is that each data set is provided of ground truth information, centroid or partition label. All of this allow us through a clustering measure, which is the cluster index, to measure the similarity, dissimilarity of a found solution with respect to the ideal one. And CIU equal to 0 mirror a structurally correct clustering. Now, we have done briefly, I understand I have no time. We done the following. For each data set, first we tried to cluster the data set using standard Lloyd's, k-means repeated, also by a great number of repetitions. You see, for example, 10,000 repetitions. And we achieved the average value of the cluster index and also the success rate, which is the number of repetitions of k-means in which we end with the CI equal to 0. As you see, in many cases, when the data set is complicated, is large, we have a low value of the success rate. As you see in the below table, in which we applied our variant, in many cases we achieve 100% of success rate. And as you see, also the time which is required to achieve a good solution is generally speaking very, very low with respect to standard k-means. And these are very difficult data sets in which we, with our method, we achieve some results which are very, very comparable to the result achieved in the literature by using more advanced clustering methods. We applied also our tool to some real-world data set, which almost are image-based data set. Also, in this case, we achieved the result which are very similar to results which are published in the literature, but with few time. So we reduced the time to achieve a good simulation, a good solution. I would only mention, for example, that for the Olivetti dataset, which is a facial recognition problem, we achieved a cluster index of 5, which means that over 40 subjects, only 5 are not correctly recognized, but which is a better result than what is known in the literature. Now, I would conclude by telling you that we are moving toward optimizing further the Java implementation of our tool and applying the algorithm also to more challenging, very large data set. And also we are engaged to port the implementation with this moment is based on Java parallel stream using our actor system, which is known Theatre, which is as demonstrated to be very efficient for high performance computing on a multi-core machine. I have it terminated. Thank you for your attention. If you you have any question, I'm here.
Sir, I think we are unable to hear you right now.
Oh, if you refer to me, I mean, I think the same point that we actually have very limited time, so I don't think we really have a time for discussion here. I wrote some comments for the previous presentation in the chat if you want to review them, and I think it would actually make sense to go to the next presentation. So if anybody has questions or comments, you can just write them in the chat. So I think that would be the best, because otherwise we will simply run out of time. And I'm sorry, like my schedule is very tight today, so I cannot be here longer than 1 hour. Yeah. Thank you.
Yes, thank you so much, sir, for respecting the time constraint. Now we'll quickly move on to the next presenter. So the next presenter for this session is Eduardo, sir. If you're present in the meet, please let us know and start your presentation.
I don't know what happened. Okay, my name is Eduardo Pinos Vélez from Ecuador. In my country right now is 5 o'clock, 5 past 10 minutes. So in this, it's a pleasure to me to be here with you. This paper is about the improvement of the calculation method of the toric intraocular lens in the preoperative process of cataract surgery at the Santa Lucia Clinic in the city of Quito. Quito is the capital of Ecuador. I'm living Cuenca, is the south of Ecuador. This work is with collaborator with Caterina and Joanna. Okay. Around the world, in my country especially too, the cataract surgery is globally recognized as one of the most prevalent surgery procedures, highlighting the critical role of the precise intraocular lens, IOL, calculation in achieving optimal visual outcomes for patients in the clinic Santa Lucia. The importance of accurate IOL calculation cannot be overstated, as they directly impact postoperative visual acuity and patient satisfaction. So the research aims to enhance surgical outcomes by refining the calculation method for the toric intraocular lens. Addressing a specific challenge relates to toric IOL calculation, particularly in the astigmatism correction by improving the accuracy and efficiency of this calculation. The study seeks to optimize patient outcomes and contribute to the advancement in cataract surgery. The objective of the research is about the study the optimized operational process and the elevated precision of the results provided the optometrists. It aims to elucidate the necessity to refine the preoperative processes to reduce the surgical duration and enhance workflow efficiency within the demanding clinical environments. This study holds significantly in its potential to enhance visual outcomes and patient commitment subsequent to cataract surgery. It underscores the pivotal role the accurate toric IOL calculation in augmenting patient satisfaction and overall quality of life post-surgery. Such improvement extends to diminished reliance in corrective airwear and headache visual acuity. This enhances the overall patient experience. For example, in my case, in my left eye, I have a IOL lens intraocular. I have a surgery in the same clinic with Santa Lucia Quito because we have a cataract 2 years ago. The methodology. Emphasizes advanced feature design of toric intraocular lens selection, highlighting its superior precision and efficient in comparison to conventional methods. They present the substantial reduction in calculation time obtained with the tool underscoring its role in enhancing operational efficiency. Quickly, in the accurate result emphasis the significant increase the calculation time and enhancing the accuracy in the lens calculation, ultimately resulting in improved surgical outcomes on heightened and patient satisfaction. For example, in the comparison of toric intraocular lens calculation times the current method with the proposed method. This is some comparison table and some options. The methods we have in the internet, we have in the Zoom calculation from some factories or something like that. So the average is in minutes, no seconds. Minutes is too high. In this case, the studio in the Santa Lucia Clinic, Quito, the implementation has seamlessly integrated the reference calculation method at Santa Lucia Clinic, supported by positive feedback from clinical staff. Additionally, we will discuss instances enhancing surgical planning and post-operative outcomes associated with the new approach. In this diagram, this is the some calculators from the clinic Santa Lucia. This is our calculator, and the result is for example, we have some formula that varied and holiday variables, biometricas, chirometricas, and the time is in the left 2 minutes with 51 seconds approx. In the right eye, 2 minutes with 58 seconds approx. At the same time. So the result in the Santa Lucia Clinic is better for the IOL. In future implication, examine the potential to broad adoption of the calculation method in various clinical settings in around the Ecuador, emphasizing the capacity to standardize and enhance the toric IOL calculation. Additionally, pinpoint opportunities to future research aimed for referring calculation algorithms and propelling advances in the refractive cataract surgery. By the way, the last Thursday, we was in Quito working about this. We was some tests or this toric calculator, and the result is so good. I have an example right here. Conclusion. The summary case finding regards the advanced calculation method for cataract surgery outcomes and patient satisfaction highlight the crucial role to technical advancements in advancing ophthalmological surgery emphasizing the necessary for ongoing innovation. If you permit for me, I can show you a little example, please. Just a second.
Please go with the next presentation.
Okay. It's very quickly my presentation. I have the paper, but I will try to show you an example from my good calculator, but I have some problem. Okay, please let me show you. It doesn't work, I think, right now. No, here. This is an example for our calculator, IOL toric. We can put the ID the patient, surname, name, phone, sex, age, email, something like that. Some parameters what the specialist give us, and we can calculate about the position of the lens, intraocular lens in the eye. Okay. That's all. Thank you for your attention. Maybe do you have some question? Sorry for my English. My native language is Spanish, so I will try to speak in English.
Yes, sir. Thank you so much for the presentation and considering the time constraint. Now, if there aren't any questions, may I proceed to the next presenter?
Yes, please.
Okay. So the next presenter for today's session is Philip, sir. Sir, are you present with us right now?
Yes, can you hear me?
Yes, we can hear you. Sir, you may start with your presentation now. Just consider the time constraint as we are running out of time.
Sure.
Thank you.
It needs me to click and reopen the Zoom for sharing. Give me a minute, please. Okay, can you see my presentation? Okay.
Yes,
my
we
name
can
is
see your presentation.
Great. Hi, my name is Filip Zag, and I'm a student of Faculty of Informatic and Information Technology of Slovak University of Technology in Bratislava. And I will be presenting research paper with collaboration with Pavle Dakic, focused on creating feature model for YAML generator in CI/CD pipelines with React application. So as you can see on the agenda there, the presentation will include some introduction into the topic, analysis of research that were made in the field, and conclusion. Being effective and efficient while developing a software product is important in today's high-demand environment. Development teams try to simplify and automate routine tasks, allowing them to concentrate more on the core development process, and financial justification for continuous integration and continuous deployment. CI/CD basically. Automation, together with agile practices, has the potential to significantly decrease the time required in the software development cycle. Many businesses are adopting and implementing agile approaches such as CI/CD with pipelines to improve the efficiency of their development processes. Pipelines automate essential software development tasks, including code compilation, testing, and deployment to different environments, including development, staging, and production. The primary goal is to maintain consistency and standardize how software is released and minimize the potential for human error. So CI/CD pipelines. CI/CD automates most of a human input needed to get the new code from developer's computer through various tests and later into the development, staging, or production environment. This enables development teams to make changes in the code that can be automatically tested and pushed out for delivery. CI/CD also improves downtime since the release is faster. In case of failed tests, it will automatically roll back to the latest stable version, and it is a crucial part of any modern software development practice. It helps maximize development time and aims to reduce development complexity. YAML files, while line-oriented formats are still popular, modern programming frequently involves semi-structured data such as JSON or YAML. The extraction pipeline can be easily customized using a YAML-based file, allowing users to define the list of models along with the corresponding parameters and various backends for extracting each modality. This raises a question: how should a data integration framework for knowledge engineering be designed? As outlined in some studies, contemporary research on knowledge graph architecture recommends the establishment of facade, a term borrowed from object-oriented software engineering. YAML aims to be more readable for people, for humans, and this research paper lays the foundation to further research that should result in a based application that will have the option to generate YAML file that can be used for CI/CD pipeline in automation in a React web application. This is a feature model that we have created, as you can see on the picture. Feature model was created with use of Mobius Forge and represents functionality that is expected to be implemented in the application. The model shown on the picture contains essential functionalities with the black dot and not essential with the white. And some of the essential include the connecting to the GitLab repository and loading configuration files. This proposes a tool that generates YAML files using Python as a backend with JavaScript and React framework on frontend to provide a decent user experience. Especially, it underscores the importance of performing project analysis as it is prerequisite with the YAML file generation process. The application should be able to connect to the repository, analyze all included files, and determine the appropriate build and deployment sequence. The picture contains a proposal of the prototype of the application. So, some of the conclusions. This study tackles the problem of configuring CI/CD pipelines for React web application, and the application that should result in the end of this research should be capable of creating pipelines for a React web application. Its goal is to standardize aspects of the process in response to the growing demand for automation, the importance of CI/CD in the software development cycle, and automation was expressed. The investigation laid the groundwork for GitLab application that generates customizable YAML files for the automation of the CI/CD pipeline in React applications. We discovered that designing a tool for CI/CD pipeline production involves several essential development problems, including scalability, adaptability, and how well it fits into the pipeline. All of these must be thoroughly researched with special attention to the format of the YAML files. Although The suggested tool has limitations such as platform-specific YAML generation. It shows promise in terms of improving development productivity. This study is useful for future efforts to optimize CI/CD methods and configurations for React Web applications. We had the opportunity to assess the usefulness of automation, the CI/CD workflow, and using the YAML file format. One of the conclusions and verification is that well-structured configuration files and automated process play a vital role in optimizing software development, as mentioned previously. And as mentioned in the whole presentation, the future development should result in a web-based application with Python as a backend and front-end in JavaScript with React framework. Thank you for your attention. If you have any questions, I will be happy to answer them.
Yeah, thanks very much. I think same applies as before, that we have limited time and we cannot really open discussion here, so it makes sense to go to the next presentation. However, I already did write one question to you in the chat, so maybe you can reply in the chat. I think that seems the most efficient. So
Yeah,
thank you.
I will do
Let's
it.
move. Yeah, and let's move to the next
Thank you so
presentation.
much, sir, for your presentation. Now we'll proceed to the next one. So the next presenter for today's session is Firat sir. Sir, are you present with us right now?
Yes,
And
I
then
am.
we,
Can you hear me?
yes, we can hear you.
Okay,
You
great.
may start with your presentation now.
So I'm sharing my screen. Can you see my screen?
Yes.
Okay. All right. So you can see my screen, right?
Yes, sir.
Perfect. Yeah. So the purpose is to develop understanding of current state of computing infrastructure, and this primarily because of the potential developments, intelligent systems, and potential development in the rapid AI. We are experiencing a revolution in the development of AI systems and agents. So there's the idea is here the research outlines significant transformation of computing infrastructure resulting from improvements in intelligent systems. This is of high relevance to the industry. I have a very close relationship in the Silicon Valley industry in California, where I used to work and live in my previous life. So the research questions are basic. How will intelligent systems transform the landscape of computer or computing infrastructures? What will the potential benefits be? Risk associated with these changes? And this has an impact on both the industry and ultimately the consumer. So the customers and the consumers, right? And what industries or sectors will be most affected by this advancement? Because right now we can only read and see some of the changes that AI components are everywhere, which will have more of this. So the methodology followed a few steps here, from literature review to industry analysis, and I get quite a bit of white papers, research papers from companies in the Silicon Valley, conversations with a lot of people. Some of them are friends, some are I was introduced to, and we try to have conversation on why is it important, what do they see as important changes, and how this will affect their industry and the consumer. And this is of importance, of course. Descriptive analysis, predictive analysis, and machine learning. Some of my students helped in that, and trend analysis. So there is quite a bit of literature available, but mostly the information gained from the industry were really, really, really helpful. It's more up to date and it's more current and it guides in what's to anticipate. So to cut it short or to save some time, let me get into the findings. So the integration of intelligent systems as integral part will cause major modifications to the computing infrastructures. If you could only imagine what that means. Not only mobile devices and computer machinery, but to mainframes and everything else, including data centers, which is very expensive. So the automation of network operations and data centers, as I said, significant shift, which has made it possible for more self-managing and self-managing systems, basically. It's anticipated that this will decrease downtime and improve efficiency. I'm not sure about the cost, but decrease downtime, of course, and improve operational efficiency, which is important to the industry. Excuse me. It's also anticipated that intelligent system will enhance data processing capacities. So again, if we could imagine, what does that mean, enhancing data processing capacities, which will result in a quicker insight and permitting real-time decision-making. So the nature of decision-making within the, let's say, the organization will experience an acceleration and maybe a shift. And that's why understanding how changes in computing infrastructures affects intelligent systems. Research findings provide a comprehensive overview of how the incorporation of intelligent system is poised to transform computing infrastructures, resulting in notable transition toward automation in network operation and data centers. Now, one of the things, I have it here in the paper, and I have it in this table rather. Infrastructure scalability and security. This is some of the one of the #1 issues was raised, but really, as far as I'm concerned, is the job market shift. Automation is changing the labor market and will continue to do so. So as in new skill sets are needed for IT infrastructure management, meaning current expertise need to update in according to changes in intelligent systems. Look, we're all academics probably here. And I think personally, this need to be taken in an inductive way. So from changing industries, changing skills needed down to the university level, where we need to do fundamental redraw of what we teach, meaning we have to upgrade our programs, curricula, expertise, to make students knowledge relevant and can serve the industries. And this is really important. We are having a debate over how academia need to change, really need to move much faster than the rate. If anyone could share with me very quickly changes they're having at their university as far as program being offered or syllabus, or that will be great. So yeah, from Internet Industry 4.0, literature confirms data analysis, which highlights the significance and profound influence of the Internet of Things on many industries. AI, advantages of implementing business intelligence system in a small and medium-sized enterprises particularly are emphasized, although everyone across the board is being or will be impacted. There is a lack of comprehension of the obstacles to adoption and lasting effect on business performance. And this is, in my opinion, something to stop and think about. So usually we are in a reaction at the academic level, we're on reactory mode. We react. The industry would like to, some players react, are not as proactive. Some are. And that's why they had a lot of studies and research and data, and they were willing to share it. They wanted to see how this will impact everything else and everyone else. So this is pretty much, in a nutshell, the paper we're having here, and I welcome any questions in the side chat. Thank you very much. All right.
Thanks very much. And I already wrote my questions in the chat. So as I said before, we have a limited time, and I think we have one more presentation to go and have about 18 minutes left, right?
Yes.
Is that correct?
Thank you so much, sir, for your presentation. And now we'll proceed to the next one. So the next presentation for today is again, I guess, Edward, sir, you have another presentation. Eduardo, sir, are you with us right now? Or any co-authors, if they're present, please contact us.
I am here.
Okay.
Okay.
I'll stop sharing my screen now. Then you may start with your presentation, sir.
Okay, thank you. Can you show me my...
Yes, we can see your screen.
Okay. No, it is the other presentation. Yeah, it is. Okay, thank you. This is my last presentation. Is continue my last work, and the intraocular lens calculator algorithm for presumptive diagnosis of intraocular lenses. By the way, I use this presentation with this background. In my university this year, we had 30 years in Ecuador. It's something new. Okay. In this article, highlight the need to improve process in cataract surgery to increase efficiency and patient satisfaction. Our goal is to propose improving the calculation again in the target intraocular lens in the clinic Santa Lucia in Quito, Ecuador. By optimizing this process, we aim to reduce the process times and the waiting time for results, thus improving overall treatment efficiency. Some review of literature review, key finding from previous research in intraocular lens, biometrics, visual impairment, and clinical outcomes in cataract patient are summarized. Gaps in the current literature and the urgent need to advance diagnosis tools, such as algorithms under development, to address these deficiencies and significantly improve the ophthalmic care in the highlighted. Our methodology is developed of the algorithm for presumptive diagnosis in cataract surgery with toric intraocular lens, calculate spherical and cylindrical power, and determine the lens position using biometric and chirometric data. Comparison of the algorithm results with specialized device to assess relativity and accuracy, and the result is the high relativity and accuracy of the algorithm in improving visual outcomes in cataract patients. So this is the patient some devices in the clinic Santa Lucia, like IOL Master, and we have some parameters like biometrics, keratometrics, in the left eye and the right eye. We have some analysis of data, the validate the dates. If it not validate, discard some dates, and if yes, we use the interface, input some parameters, we calculate the parametric spherical cylindrical potential, and some processors like I forgot the word in English, suavizado, and some filters, and the diagnostic is about the determination the some astigmatism or something like that, for example. This is the some diagram, but the process inside of this is another work. Some results have relativity and equation of spherical, cylindrical, and torical power calculation using a developed algorithm. In comparison with the dedicated IOL master device, the algorithm must demonstrate optimal performance and optimizing visual outcomes for cataract patients. Pearson correlation analysis and Cronbach alpha coefficient. The results showed excellent modeling with the average person coefficient of the 0.999 in the supporting the accuracy and relativity of the developed algorithm. In some results in this table, we can some comparison about some the lens type. For example, some the fabricators or commercial house, visual anchors, visual trifficatorics, alcontoric sampling, alcompanotoric, and we have a very large list of these some house commercials. And the radio of the spherical power is something like in this table, and the radio of the cylindrical power is like this, and the radio X is like this. So we when use with our calculator, the result is more quickly, and
Sir, extremely sorry to interrupt you in between. Can you please enlarge your slides?
okay.
Just make it full screen. Some of the people are not able to see properly. So,
Okay, I understand very good.
just there will be one icon, full screen icon. You just have to click on that, and then this will be displayed on the whole screen instead of a small box like screen.
Okay, I'm not sure about that, but maybe
Uh, okay, or can you just like increase the font of the slide?
increase
Yes, on your laptop you can do Control plus, and then it will get enlarged.
like this. It's okay.
No, actually,
I would say that we are viewing the previous presentation.
okay, it's okay, sir. You can continue. It's fine. It's fine. Sorry for the interruption.
Okay. I must finish. So clinical implications. The development algorithm showed the relativity and accuracy in calculation of spherical and cylindrical power and toric length placement in the eye, thus improving visual outcomes for the patient undergoing cataract surgery. The clinical application of this algorithm can improve the accuracy for toric IOL calculation, result in better correction of the corneal astigmatism, and improve the post-operative patient satisfaction. And develop presumptive diagnostic tools provides accurate guidance for intraocular lens selection and placement in patients with cataract and astigmatism. Some future jobs is evaluation in real clinical settings. We are right now in Quito. Expand the scope of the algorithm, considering that attend the algorithm, the other mixed surgeries and refining in disability optimized visual outcomes and incorporating the emergency technology. For example, explore the incorporation and, like you said before, artificial intelligence or other technology to improve the accuracy and efficiency of preventive diagnostics in the alternative patients. Conclusion is the importance of accuracy in the calculation of spherical and cylindrical power and the torque length, position using the developed algorithm. High relativity and accuracy of the algorithm compared to specialized devices, and the utility of the algorithm to optimize visual outcomes in patients undergoing the cataract surgery. It's important to know that, for example, I have a intraocular lens in my eye, but it's not only putting my lens in my eyes. We need to calculate the position, the rate, the angle of the collocation in the lens in my eye, because the dioptrias, I'm not sure it is in English, dioptrias, for the regular my vision, my angle of vision, and this is the importance of this work. So that's all. Thank you for your attention. Maybe you have some question. I'm here, and this is my email. So thank you.
Thank you, sir, for your presentation. If there are any questions from chairs or participants or presenters, you may ask right now. If there aren't any questions, may I proceed to the closing remarks and end the session?
Yeah, I mean, sure. I mean, thanks very much. I mean, all the questions or comments that I have written in the chat, just to save the time. And thanks everybody for their presentations. They were quite diverse. Enjoyed it very much. And thanks also giving your good answers in the chat. So this is basically what I have to say at this point. Again, thanks a lot and enjoy your day. I hope that others have also some comments or questions here. So thank you.
Thank you so much, sir, for your wise remarks. Now I'll proceed to the closing remark. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the 9th version and all the previous 8 versions. We look forward and hope we will be happy to see you in the 10th version in 2025. All the presenters would be getting their digital certificates via email within two working days. And further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT. I thank our session chair, Mr. Milis Kitsing sir, and Dr. Nimisha Patel ma'am, for chairing today's session. Thank you so much for chairing today's session. Let me just share the screen. A token of appreciation to the chair on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you everybody for your valuable presence. I hope you enjoyed and found this session knowledgeable. Before we end the session, I have a request for everyone. Before ending the session, there is one small request from my side. Can you, everybody can, I just want to take a quick snapshot of everybody. So can you please turn on your cameras if you don't mind? Thank you so much. I'll just take a quick snapshot. Thank you very much, everybody. Now you can end the session and